Welcome to Day 6, Masterclass 2021, An Introduction to QGIS for Beginners by Ms. Opeyemi Kazeem Jimoh, a case study on application of Geospatial Machine Learning in Agriculture by Ms. Aditya Allamraju.
Yes, hello and welcome to the QGIS session of the masterclass. My name is Opeyemi and I'll be taking us through a beginner's introduction to QGIS. I'll be taking us through downloading the software and some basic workflows for a beginner. Now, understand that we only have about 20-25 minutes for this tutorial or this session, so I'm going to try as much as possible to fit in everything that I can into this. So please bear with me. I'll be sharing my screen now to see a set of slides that I prepared in advance, and it help us go through this session hitch free basically. So okay, great. So, okay, like I said, my name is Opeyemi, and I actually work as a GIS analyst for GRMI. It's an environmental initiative based in Lagos, in Nigeria, and we work basically with disaster risk reduction and mitigation. In the line of my work, I work with geospatial software and data. And one of the software that I use basically is QGIS. I also use a host of others, but this tutorial is targeted basically at QGIS for beginners. So I'll be walking us through a few of the things that we would, talk about here. And basically, in this tutorial, I hope to share with us basic introduction into the software, its history, available versions, and the latest version as well. Also talk us through or take us through the steps involved in downloading and installing the QGIS software. I'll take us basically through the GUI, that's the graphical user interface. I'll also walk us through a few of the workflows that beginners might find interesting, or which is, basically basic workflows, basically like adding raster data, adding vector data, creating vector data through digitizing. And if time permits, I would like also to walk us through a bit of georeferencing, which I think is actually very fun and is something that even a beginner can get into and enjoy. So basically, I'll also take us through or a basic introduction into plugins, which is a vital aspect of QGIS and one of its major functionalities. Also, the Python console, which allows for automation and programming, you know, basically for the user interface. Now, introduction. So what do we understand by a GIS software? Basically, a GIS software lets users visualize, question, analyze, edit, interpret geographical data, basically points data or line data or polygon data or image data, anything that we could use as a representation of the earth that we live in, that it's locationally relevant, basically. So basically, any locationally or geographically relevant data can be visualized, analyzed, questioned, edited, interpreted, managed in a GIS environment. So basically, GIS is Geographical Information System. So basically, this is a software or a software that allows us to do this is a GIS software, and it's usually targeted at understanding this data to provide problem solving relationships and understand the patterns and trends that occur within the data basically. So QGIS particularly is a free and open source desktop GIS software. So QGIS, first of all, is free, and it's open source. So basically, you don't need a subscription to work with QGIS. It's free, and everything that goes into its development and updates is usually done by volunteer developers and agencies that just want this important software to be available to all. So this basically means that it does not require any subscription, like I said, to access and use to its maximum functionality. And it does basically everything that you want a GIS software to do, like I said, which is analyze, manage, edit, understand, and interpret geographical data. So, like I said, any and all major GIS functions can be performed using QGIS. And with the use of plugins, like I mentioned earlier, what I'll also explain further as we go on. With the use of plugins and the Python console, the capabilities of the software for geospatial analysis is truly limitless. Like there's so much you can do with the GIS softwares available, and particularly QGIS. And the fact that it enables for use, the fact that it's constantly updated, the fact that you are able to add, or you are able to use in addition to what you have already, constantly evolving plugins, and all those things make its functionality basically limitless. You can everything that maybe you could find a workflow that you were not able to do today, and by tomorrow or next, by the next update or the next plugin, you'll find that somebody has already updated it, and it's basically constantly evolving with the trends and with the necessities of the geospatial world. The software is constantly evolving, mindless of the fact that it is free and you don't have to pay for anything. You get to use it to the fullest capabilities, and that's one thing that I feel it's very important about KGIS, and one of the reasons why I particularly like it. So, like, what are the key benefits of QGIS? It is free with and requires no subscription. Like I said, it enables the use and development of plugins independently. So, for example, plugins, like I said, they're a very important part of QGIS, in the sense that, for example, you have a workflow that you think that, oh, QGIS should be able to do now, but can't do it. I'm talking in the sense of more advanced users now. For example, as you go more advanced and you feel that, oh, there are some functionalities that you would want to work in QGIS, but they are not available currently, probably because somebody has not thought to do them already. You, as a user, QGIS offers you the ability to be able to create your own plugin. You can create the plugin and make it available in the repository for others to also use. One example of this is the SCP plugin, which is the semi-automatic plugin for land use, land cover classification, for basically image classification. And it was one thing that before its advent, sometime last year, we were not really able to do much on image classification, supervised image classification using, machine learning algorithms. But with its introduction by Luca, a lot of people, it's become very popular, and it's made things much more easier in terms of land use, land cover classifications for us in the geospatial community. So that's one of the importances of QGIS, and why it's very applicable all over. The fact that when you don't find a functionality today, by tomorrow somebody has developed it, or you could also develop it and add it on there for everybody to use freely. That's very important, and that's one thing that is really good about the QGIS software. Also, it has an easy to navigate use and user-friendly graphical user interface. And as we go on in this tutorial, I'll take us through what the GUI looks like, and we'll get to work with it basically. So, history and versions. QGIS has been in development since early 2002, and in the initial stage of it, it was basically a way, Gary Sherman wanted to find a way to make grass to make grass develop a user interface for the grass suite of algorithms. And he basically wanted to create, and basically at the end of the day he came up with the first ever sort of version or release for it around late 2002. But it afterwards it became a when people got to see how important the QGIS is, and the awesome potential that it had, it became an incubator project of the Open Source Geospatial Foundation in 2007. I think the first version, or version 1.0, came out in 2009, if I remember correctly. And as of 2017, QGIS is available all over all types of operating softwares or systems, and it is basically world globally used and applicable. It's one of the most important and most popular GIS softwares that we have out there. Basically, okay, like I said, the versions QGIS 1.0 came out in January 2009, and the latest version of it is the QGIS 3.20, or Odensor. This is the flyer in the background. I feel if you could see that. This came out in June 2021, and it's the richest in features. Basically, it's the latest model of QGIS, and it has most of the latest functionalities that you would ever want, or basically what QGIS is. Basically, this is the highest version of it. Although there's a difference between having the highest version and the long-term release. The long-term release is usually recommended as the most stable form of it, that has less bug issues and that has more of stability because it's been tested and trusted over a period of time. So the latest release or latest stable version is the version 3.16 and over, and luckily that's what we'll be using in today's tutorial. I have it downloaded already, but I'll also walk us through how to download it. Now, for more information on the version types, history, and specifics, you could all go through to the QGIS website, that's qgis.org. Downloading and installing the software and the graphical user interface. So right now I'll take us through to my browser and try to walk us through how to download the QGIS software. Well, I have steps here that we could look at. Okay, so these are the steps I'll be walking us through. On any search engine, type in download QGIS, or QGIS latest version, or QGIS version, or whatever you want to download regarding QGIS. Or you could go to also to this link and download the appropriate version for your operating system. For me, I have already downloaded the 64-bit Windows version of the QGIS 3.16 and over, but I'll also walk us through that now. So let's go to the browser. So my browser now, I'll take us through to, okay, like I said, you could just click or type in download QGIS, or just type it in, or you could go to, and to take you straight to that link I shared earlier. So basically this is it, and when you get here, you usually download the one, this is the version 3.20 Odensor, the latest version, like I said, but as it's stated here as well, the most stable is the 3.16, and that's what I'll be using. So I'd advise also that you download, the standalone or the latest and the long-term release. Yes, that's the most stable. Or if you want to use the latest version as well, it's you could. But for this tutorial, I'll be using the ANOVA, that's 3.16. So if you want to download for a 64-bit laptop like myself, most laptops are 64-bit, but if you want to be sure, you could go to your laptop properties. I could give you an illustration of that quickly, if you want to, for example, if you're using a Windows 10 like myself, you could just go straight to the settings. When you go to settings of your operating system, your Windows, go to system, then from system, it's taking a bit of time. Okay, from system, then you go straight to about. Yes. So you know about the type of operating system that you have. So like you can see, mine is the 64-bit operating system, and that's why I would advise if you're using a Windows 10 like mine, you want to download this. And once you download the 64-bit, once you download it, it downloads an executable set of file, and I have that illustrated here. Already I downloaded, so I won't be downloading again. But from what you will get if you have downloaded, I'll be taking us to the folder that I have as that's QGIS tutorial. Um, okay, wait, here it is. So this is the software, the 3.16 software setup. So once you have it downloaded, this is what you would get, and you could just double click on this to run. And when you run, you go along with the flow basically up until you get to the part that says finish. When you click finished, you have it installed on your system. There are a lot of tutorial resources on how to properly download, and if you have any issues that you might get, how to fix those. There are tutorials on that online, so I won't be going in depth into that. If you have any issues, you could just consult YouTube or yes, or any of those tutorials. There's so many awesome resources on that. So okay, so once you already have that, once you've gone through this stage, you might not see it. Okay, you might go to your program files on your system, or I like to go to my Windows. Once I get to Windows, I'll see the recently added ones, right? So recently downloaded and installed apps, I have them here. So from here, I will just click on the QGIS desktop 3.16.2, which is what I just downloaded and installed. And I'll double click on that, and here we go. Here we go. It's already opening. Now I've double clicked to open, and we could go on in our presentation to the next things. Yes, so now that I have downloaded and installed and opened, this is what the graphical user interface looks like. This is the GUI, and this is basically how you interact with the software as a user. So basically, this contains everything that you need to work on your geospatial or geographical data. And I'll just be taking us through a few of the important things to note on the GUI. These are the taskbars, the panels, my favorite panels to have, the layers panel, browser panel. And yes, so I'll take you through. So basically, this is the menu toolbar, and it contains basically like any software would have. You have the menu and everything contained in how to work with your software. So here you have the layers panel, the view panel, the edit panel, the project panel, which is very important. Here you get to create new projects or open an existing one. You get to save or save as. Also, you get to create a new print layout. So basically, if you want to do a map and you want to print out a printable map, here is where you access that. Also, we have the map navigation toolbar. Here you have your pan, or your zoom in and zoom out, and all those things there. Then one important panel that, or two important panels that I don't joke with. are the layers panel and the browser panel. So basically this browser panel opens up everything on your memory, on your system memory that could be of use to you. So basically everywhere where geospatial data could be stored on your laptop or on your computer, everything is here basically. So it's like a database where you can access all your files and all your data sets. Now, this is the layers panel, or you can call it the table of contents. So everything that you have populated in your user interface, you have it here. So for example, if you have a new layer, the layer name will come up here and you can access the layer there and work with it. Also, you have here your coordinates, your scale bar, magnifier, renderer, and also your coordinate reference system is always represented here. So let's move directly into adding data, right? So okay, for example, I'll take us back to the presentation and the basic tasks that we'll be covering in this tutorial. So give us a bit of context. So to be covered in this tutorial, I'll be walking us through adding raster data to the GUI, adding vector data through these various sources. You could go via the data source manager or via the manage layers toolbar or via the browser. Okay, so once we're done with that, then we'll move into the plugins as well. So basically, this is the graphical user interface, and I have a data source or data set that I'll work with. So I'll just take us through how to add this. Now, if you want to add through the data source manager, you could go here and click on add layer. There you see the different types of layers that you could add. I have here the vector layer and the raster layer, as well as a lot of different other layers that you could add to your GUI. I'll be adding a vector layer first. Now I'll go through this step. Then when I want to add the raster layer, it's basically the same thing, but I'll also take us through the browser using the browser. So I want to add a vector data set, and I have one here in my folder that I have created for this session. That's the QGIS tutorial area of interest. So these are the different data sets that I'll be using for this tutorial, but my vector data set is here, which is the boundary of the area of interest I'm working with. And here we have the shapefile .shp. That's the one that we want to work on. But we have to make sure that our shapefile is within a folder or within a place that also has all these other types of files pertaining to that particular area of interest. And I know that we are geospatial people, so we already understand basically what this means. So yes. So this is my boundary, and I'll just leave all these options as default and add. Right. So here I have my layer, my boundary for my area of interest. Now this place, you don't know what it looks like now, but it's actually a plantation, an area of a plantation somewhere in southwest Nigeria. Okay, so for a bit of context, I'll add a base map now so we can see sort of where we are in the world. So I'll add a Google satellite base map for us to see. All right, so basically, this is what we'll be working on, what I'll be working on today. Oops, isn't that too far? Yes, so basically this area, this is a shapefile of this particular area in southwestern Nigeria. So you see that we've added a vector file. It's that easy to add a vector file, right? And this is actually a boundary and a boundary extent for us to see clearly what we have on the surface of the earth on that base map. I would just like to change the layer styling. And how do you go there? You could go through properties, and you go to the symbology aspect of it, right? You go there, and I would like to give this a transparent feel, and I'll give the border a red feel, and just increase the stroke width a bit to make it more conspicuous. And yeah, here we go. So basically, this is the boundary of this area. It's called Okomo, and it's in southwest Nigeria, in Edo State particularly. And yes, so you see how easy that was. Now, this is a base map, and if we're used or familiar with GIS or maps and map making, we understand what base maps are already. So now that I have added my vector data, see, it was that easy. Now I'll be adding a raster data, and the raster data set that I'll be adding will be the DEM for the DEM file or data set that I downloaded for this particular area on the USGS Earth Explorer. I downloaded it in advance. So basically, I'll just be adding it now. So I'll be using the browser panel this time around rather than going to the data source manager, just for us to see how this is done through the browser panel. Now, I have the folder stored on my desktop, so I went to home on my browser panel, home, then desktop. Then the folder is right here, QGIS tutorial. Then from there, I'll take us to the AOI folder, and that's where we have the DM. And this is the DM that I previously downloaded. It's right here, and I'll be adding that. So you see, this is the DEM for the area that I downloaded in advance. So one cool thing that I'll be adding, or that I'll be showing us here also, is how to extract the DEM, that's the raster, by mask layer, that's the vector. So we'll be extracting or clipping our area of interest to just that boundary. We'll be clipping the DEM to the boundary of our area of interest. That's one cool thing I would like to show us as we go on. So now we are clear on how to add raster data and how to add vector data. So for now that we've added this, I'll show us how to clip the DEM, that's the vector data. Now DEM is basically digital elevation model, and it shows the elevation of that particular area. The elevation, that means like how high or low it is above or below sea level. So for the area that I have downloaded the DEM, I will now cut or clip or extract by mask layer. And to do that, that's one of the processing functionalities of QGIS. And to do that, I'll go to raster, that's to raster, and raster extraction. That's where we get clip raster by extent or clip raster by mask layer. Now we'll be working with mask layer since we already have our mask layer. Now the input would be basically the raster layer that we want to clip, which is the DEM, and the boundary will be the mask layer. Now for all this, we could leave it as default, so it will take on the CRS of what we have for the input and output. Now for the specific no data value, it is kind of convention to use the value to just set it as a value, rather 0 or -999, and then we'll just leave the rest as default settings as default, and then we would specify an area or a file to save or output to. Now I'll be saving it in the folder that I've created for this presentation, and I'll just save it. I could just save it as a common clip, right? So let's just keep it as that, and we'll save, and basically just run the algorithm, and we'll have in. Yes, we already have it. It doesn't take a lot of time at all. And here we already have the clipped version. So for us to see it properly, we could just uncheck the major DM layer, and we'll see it right here that it's been populated. So basically this is the DEM for that particular area. So that's a very powerful tool to know. It's basically, let me take you through that again. It's raster extraction, clip raster by mask layer. So if you have a data set like that that you would like to clip to a particular specific area that you have the shapefile for, then that's the way to go. So we could just, rather than uncheck, we could just remove this since we won't be needing it anymore. It's also a safe step to save your project. So you can save this project as, we could save it also in the folder that we already created. That's QGIS tutorial, and I could just save it to be saved as a GIS QGIS project file. Excuse me, and I'll just save it as tutorial. Okay, so we'll just save this project. So this project is saved in case anything happens and we need to leave immediately. So one other way, this doesn't look very lovely as it is, we could just style it. That brings us to layer styling. So to style raster layers, we could just click on this open layer styling panel, and it takes us directly to the styling for this particular layer. Or we could just go click on the layer and go to the properties for the layer, and it takes us to basically the properties, and under symbology we arrive at the same layer styling panel. So for let's do that again. I'll go straight to the layer styling right here. And for raster layer, you could change the type, you know. I'll be using the styling type. I'll be using the single band pseudo color, which is usually convention for styling raster data, depending on what you're working on. But for random styling, it's usually the single band pseudo color. And to see how that looks, you could just click classify. And here we are. This is it. And okay, basically, this is the legend. Sorry, I didn't mention that earlier. It shows here that, you know, areas of below, this areas in red are 3 meters below sea level, while the areas in blue are 117 meters above sea level. So that's basically what this represents. It shows us, you know, the elevation, like I said. So this styling might be a bit counterintuitive because, you know, lowlands and low areas might be represented as blue. So if we want to change the way the color scheme runs, we could just invert color ramp, and it gives us something more intuitive in a way. We could also change the type of color ramp we have, or the colors. We could change it however way we like to show the variation in the elevation. I'll just keep it this way. So apply, and you already have it. You could also reduce the number of classes by, you know, going to equal interval and changing the number to maybe 3 or 4. But I think I prefer 5 classes. So that's what we have, and that's that, right, for raster styling as well as clipping to mask layer. And that takes us basically to plugins. And, you know, like I said initially in our introduction, I said plugins are very important aspect of QGIS, as they allow you to expand on the functionalities of the software, and it helps you to apply more. So basically, if you want to access plugins, you have to go down to the plugins, um, the toolbar, right? On the menu bar, just go straight to plugins and just go to manage and install plugins, right? So that's where the plugins are on your software. So if you are booting your QGIS, sometimes you'll notice that in the booting process, QGIS loads all the plugins that you might have installed already on your GIS so that it just retrieves them. So basically, there's a large repository of all the plugins that you might need that come with QGIS, the version that you are on. So there are so many, so many. There are many, so many that you might not need to install every single one, right? But you could just find some interesting ones that you could quickly install. And some of the ones that I would recommend for us are the Quick OSM, the QGIS resource sharing plugin, QGIS to web plugin, semi-automatic classification plugin for land cover classification. So I'll just try to introduce us to those plugins right here. There are so many. In fact, there are so many installed already on my laptop as well. You could just Google or just explore them yourself. And thankfully, when you click on the plugin, you get a sort of intro to it. So just like a one paragraph intro to what it does. And sometimes you could just go through this plugin section and just go through some plugins and see ones that might be interesting to you eventually. It's a fun way to pass the time, you might say. So let's see quick OSM. OSM. Just Google. No. Quick OSM. So I didn't get the spelling right. So let's go back there again. This time around, we have to get spelling right, right? So that's quick OSM. So right here, this is what it is. Now, Quick OSM is a very interesting plugin that helps you to get OSM data directly on your QGIS in QGIS. So, for example, if you need some, OSM OpenStreetMap is a very amazing database that is regularly updated, and it contains featured locational geographical data about the world. Really, it's in fact it's the largest global atlas. It contains data sets on buildings, on roads, on shape, on country boundaries, admin boundaries, on water, on any type of data you're looking at or looking for. OSM has a lot of data, and this plugin helps you to access that data directly in your QGIS. So basically, let's just read through this. You can open local OSM or PDF files on this. Using this, you can download a lot of different OSM data on this, and it's quick. Actually, it helps you to quickly access it, the OSM data. This, as well as OSM quick map services, helps you to this OSM quick map services helps you to search through the OSM database as well. So they are interesting plugins to have. Let's just do an example with this quick OSM and see what it can do. For this area, I might not have, sometimes data that you might be looking for might not be available, but it doesn't hurt to check. As long as it's available on OSM, OpenStreetMap, you can get it here, but you need keys and values and all those interesting things. For example, if you're looking for an area or a place name or something, the key that you would want to use is a place key. There's everything that you need to know about keys and all those values and stuff you can get online. Just Google. You could Google or just go through your browser and just type in the keys, what type of keys to use for what. For example, if you want to look for cities or populated places or local government areas or other administrative things like that, you use place, for example, cities or place. Now, this is place, right? The key to use is place. I want to say I'm looking for the towns or the villages, or let's say it's village within in, and it helps you to show Is it in, around, canvas extent, layer extent, right? I want to use canvas extent, right? Canvas extent, then what it does is it just goes, it searches for all those things, all the villages that fall within this canvas extent, right? So I don't even have to specify the name of the area I'm looking at. You could just go to canvas extent, right? So to go, make sure that you are, click on advanced. Make sure that you click the nodes, the points. Since they are cities, points and nodes must be clicked. I always tend to leave everything just to see what OSM has to offer. But if you're looking at cities or towns, that would most likely be represented with points. You could just make sure that these points and nodes are clicked. Then I'll just run query. There are sometimes that there is no data for where you're searching for on OSM, and you have to understand that. But here, thankfully, we have data for where I am. And you see, I clicked for within the extent of the canvas that I was, and I got everything for within that extent. So these are basically all the villages that are available on OSM, OpenStreetMap, that fall within my canvas extent. So for example, now if you look at this, okay, so I see that there are areas, there are village areas as well. There are areas that are represented on quick OSM. For example, these are the areas, but I don't want to work with those areas. I don't want to consider those areas, so I could just delete this. And one important thing to know about, I could just remove this layer, is that all these files, when they are downloaded, they are temporary files. So if you want to make any temporary file permanent, you could just click on this icon here, this temporary scratch file only, and just make permanent. You could save scratch file, right, to make this permanent. But I don't want to do that now. Basically, what this does is just, you can just specify a file location that you'd like to save that to. But I don't want to do that. I want to go a step further, and I want to clip my area, right? I want to click this area I want to click the point by mask layer, or by this boundary that I have. So basically, I want to consider just the points that fall within this my area of interest. So what I can do now, this time around, we're not extracting by mask layer. We're not trying to extract a raster by a vector. This time it's a vector by a vector, which is a point layer, and you're extracting it by the boundary, which is the polygon layer, right? So what you can do then is use the clip. You have to use clip in that sense. So data management, no, you go to geoprocessing tools under your vector layer, under your vector toolbar, and go to clip. This helps you to clip vector layers amongst themselves. So let's say the input will be the place, the scratch file, right? That's the input. Then the overlay layer will be the boundary, and I could just save this as just save to file. Save to file. I'm saying Okomo village, right? So those are the villages that fall within that boundary, right? So I'll just run that. So here we are. We have this. So now that I have this, it's clipped. I could just uncheck this, and you see that only the villages that fall within that boundary are represented. And with that, I could just remove this layer because I don't need it anymore. So these are the villages, right, that fall within that boundary. And let's just check the attribute table. Right. So yes, thankfully they are populated places and they have names. So these are the names of those areas, right? So we could even just try to style them, right? You could just label them and make sure that we see the name. Make sure that we're saving. Let's see. So if we want to label it and make sure that the names are represented on the map, we'll just do layers. single layers. So see, it's represented here already. The field that we'll be working with is the name, and let's just see what it gives us. See the styling. So this is the default styling. Usually one won't want to use default styling, so you might want to just tweak the styling as you wish. You want to change the color, the shape, the size. You could do all that in the properties bar, layer properties. And well, I won't be going deep into that now. So let's just leave it as it is. So see, you see a very interesting part or usefulness or functionality of the Quick OSM plugin and plugins generally. See what plugins can do. Other plugins that I would also like to tell us about is, there's the QGIS resource sharing plugin, and that's also one very interesting plugin, right? It helps to share resources created amongst QGIS users. So here it is. I don't have it downloaded or I don't have it installed already, so I'll just click on that. Right here, this is it. And okay, yes, I already have it installed. Oh, I already do. So in case you don't have it installed, you could just reinstall if I wanted to, but I don't want to. So it's installed on this system, but if you don't have it installed already, you'll see an install plugin bar here, and you just click on that, and it takes a few seconds to install, and you have it right there. And what it does is that resources that have been created by other QGIS users, you could also tap into them, and it's actually a great way to share layer styling and point styling resources. It's actually a very interesting way to share SVG point styles, the different types that people are using, and it's actually very interesting. For example, see these amazing icons that you could use to represent points. So this is the animal silhouettes, this is the animal tracks and signs, different types of SVG signs and stickers that you could use. Sorry, I said stickers. Signs that you could use to represent your data on your map. There are so many others. I think I have a few installed. Okay, I only have this campaign one installed. Yes. And they were not created by me, but they were created by others that made it available on this Alina's repository. They also made it available for other users like myself to use. And that's very kind of them. You could also create, if you're interested in creating your own SVG files and are interested in making them available for everybody, there are ways to also get your own repositories onto this, right? So, for example, if I wanted to install this now, I could just quickly install this and maybe use it to style the points that I already have populated. That'll be fun. Let's try that. So I'm trying to install an animal silhouettes and Lina's repository. Yes, and it's successfully installed. I have 35 SVGs, new SVGs. And let's see how to use that. So for example, if I wanted to just represent these points instead of these boring yellow points, I want to make them fun SVG points. Basically, remember that you have to use it within context. So if this was an actual project, the fun type of SVG markers might not be appropriate, but here, just to let us know the functionalities of it, I could just, that could pass. Let's just try to see what it can do basically. So yes, so we'll go to the layer and layer properties of the point layer itself, and then single layer. Okay, so we'll go to the symbology and the marker. This is the marker, and we'll try to edit the marker. What type of marker do we want to use? We want to use an SVG marker, right? So this is different types of markers that you can use. I'm going to use the SVG marker here. The SVG marker is right here, and I'll just change. It's showing you what type of SVG marker. I've not decided on which one yet, right? So I could just go and just go straight to my SVG images, the SVG groups that I have. These are the ones that come with QGIS defaults, right? There are so many amazing ones that you could use here that come with QGIS. So, but I'm not going to use those. I want to use the ones that I just downloaded, and they are under collections, right? So under collections, right, I see the animal silhouettes that I just downloaded. I'll check on it, and I see those amazing icons I could quickly use. And I could just want to use very fun one here. It might not be context appropriate, so be careful with how you use them. Don't get so excited. But I'll be using this lovely orc here, and I'll just try to change it. It's an SVG marker, so thankfully I could change the color. Change the color and the size. Let's just change the size a bit so it's a bit more conspicuous. Okay. So yeah, I think let's see. So oh yeah, so it's right. So you see how lovely that is. So this is one of the amazing things you could also do with QGIS. You see, I was able to import a new SVG marker and use it in my project, and it's just beautiful. Another cute plugin, and that's all due to the fact that we could use plugins in QGIS. Another plugin that I would really like to share with us is the QGIS to Web. The web plugin I find actually amazing. Unfortunately, I might not be able to show us properly how to use this because it will take a bit of time, but it's worth knowing about. Basically, you could generate a web map from your current GIS project, either as open layers, leaflets, or Mapbox GLJS. It replicates as many aspects of the project as it can, including layers, styles, and extent. No user-side software required. So this is a very lovely part, very lovely functionality of QGIS. It helps you to create web maps, basically maps that you can open on your browser and interact with, interactive maps that are just amazing. And you could even send it to others to open. So initially, before this QGIS, you could not, share web maps with people that don't have the software, So, but with this, for example, if I wanted to use this for this project I'm working on, say for example I'm done with the project and I want to share it with people that don't have the software, or even people that are not GIS literate, but they want to interact with your project and with your map. This QGIS to Web is actually, and once you have it installed, is something you find under the web toolbar and create web map. Unfortunately, I'll be able to go into that now, but it's awesome to know more about, and you can get resources online that explain this in detail, and that's just awesome. The last plugin that I would like to talk to us about would be the SCP, semi-automatic plugin. And this is, in fact, this is one of the amazing plugins. I was created by Luca, a PhD student, when he was a PhD student, and it was okay. So the author on QGIS is Sandro Mani, right? So this plugin is great for land use, land cover mapping, and classification. It's an awesome way to perform supervised classification methods using machine learning algorithms in QGIS, and it helps you to create land use, land cover maps. For example, the one, I have one of them here, but I may not be able to access that now. So I know we might know about land use, land cover mapping. It helps, it comes in handy in biodiversity conservation, in tracking urban sprawl, urbanization, all those kinds of, all this how to track change in the landscape over time. Land use land cover mapping comes in handy there. And this plugin helps to, you know, it helps to automate the process and helps to achieve it in the QGIS environment, and it's very awesome. So that brings us to the end of our tutorial per se session in today's masterclass. I hope it was fun and I hope we enjoyed it. Um, the Python console is something I also wanted to introduce us to, but because of time constraints, I'll just share with us what it looks like and how to access it. So basically, it's also under the Python, it's also under the plugins. That's where you find the Python console. So basically, Python console gives you the functionality of programming, of coding right in your QGIS software. So if we already have a background, or if you have knowledge of coding, of using Python language to automate processes in our workflows, that's more of an advanced type of work. But if we're interested in it, it's a very fun way also to learn Python, and Python in terms of geospatial analysis. And there are also a lot of amazing tutorials online that are free and accessible that would help us to grasp fully the meaning and application of this console and everything that it has to offer. So, well, this amount of time will not be enough to cover everything QGIS is, but I hope I was able to introduce us to many of the basic functionalities as well as the amazing things that you could do with QGIS. So, and thank you so much for having me at this tutorial session slash masterclass. It was awesome, and it was a pleasure bringing it to us. And thank you so much for having me. So thank you so much for having me, and I hope it was an amazing session for us. I hope we learned a lot as well. And so that's it from me. Bye.
Hello, women in geospatial. I hope you're doing great. I'm so happy to welcome you all to the GeoSakhi Masterclass. I will be going through the topic of a case study on applications of geospatial machine learning in agriculture. Before diving deeper into the topic, let me introduce myself. I'm Aditya Allamraju, currently a graduate student in the University of Illinois Urbana-Champaign, USA, with a professional science master's degree in geographic information science and cartography. I'm also a proud IEEE Geoscience and Remote Sensing Society social media ambassador for Region 1 to 7 from January 2021. You can always know more about my education and experience from my LinkedIn profile. So let me introduce you. Crop identification and crop area estimation can be prepared fairly successfully using satellite sensors operating in visible and near-infrared regions of the EMR spectrum. However, data collection can be erratic due to problems of cloud cover at critical stages of crop growing season. The all-weather capability of synthetic aperture radar imagery acquired from satellites provides data over large areas whenever crop information is required. At the same time, SAR is also sensitive to surface roughness and should be able to provide surface information better than that of optical imagery, such as agriculture system characteristics. Accurate information about crop rotation is essential for administrators, managers, and various government departments for assessment, monitoring, and management of various resources for crop escalation. 29. Level 1 GRD product Sentinel-1 C-band scenes are acquired in the interferometric wide IW Swarthmore during the period from November 2017 to November 2018, which is one crop cycle, over Kumaon region of Uttarakhand state in India, which were utilized to explain the feasibility of multi-temporal SAR data for crop rotation. So here I want to share my undergraduate research on the topic titled Assessment of Crop Rotation using Multipolarized Sentinel-1 Temporal SAR Data over parts of Kumaon region of Uttarakhand. This study aims to analyze Sentinel-1 SAR data for its potential to map different crops in agriculture fields using multitemporal data over Kumaon region. In order to achieve this aim of the research, 4 specific objectives are expressed, which are: first one states to develop a procedure for reliable processing of Sentinel-1A SAR images. Second, to explain the feasibility of multitemporal SAR data for crop rotation. Third, to study the present status of different crop cover using SAR data. Fourth, to monitor the temporal changes in crop pattern with principal component analysis of SAR imagery. So this slide shows the source of acquisition of SAR data, which is the European Space Agency ESA Copernicus Open Access Hub. Here it shows the methodology of the research. So first we are doing the data acquisition, which is Sentinel-1A, which has 12 days temporal resolution. Then it comes pre-processing the data. Pre-processing the data consists of 3 main important steps: radiometric calibration, in which we also do linear to dB scale conversion, and then terrain correction, and then speckle filtering. Then we layer stack the images based on the seasons, which are Rabi season, VV and VH polarization, and then Kharif season, VV and VH, and the combined season, which is Rabi plus Kharif season for VV and VH polarization. Next, we do the main machine learning algorithm for images, that is principal component analysis. Here I've also done the unsupervised classification. Unsupervised classification is mainly used when you don't have pre-existing field data or detailed aerial photographs for the image area and the user cannot accurately specify training areas of known cover type. And then I've compared between the output of principal component analysis of VV and VH polarization to identify different crop rotation areas, and then I generated a change detection map and statistics, and finally the accuracy assessment with confusion matrix. So what is principal component analysis? So it is an important machine learning technique for dimensionality reduction. Principal component analysis transforms the information inherent in the multispectral remotely sensed data into new principal component images that are more interpretable than the original data. It compresses or reduces the information content of number of bands into few principal component images. So generally, the principal component bands are three, where the first band consists of around 97% of the information, the second band around 3%, and the third band almost 1%. So most of the information we have already acquired using the principal component band number 1. So this is the principal component analysis image which is generated for whole season VH polarization, and this is for VV polarization. So the results show that wheat crop to paddy crop is the highest practiced crop rotation with 27.95% coverage, whereas mustard to sugar cane is the lowest practiced crop rotation with 2.86% coverage of entire area of the study. So that means in Rabi season, the wheat crop is being rotated with another crop in the Kharif season, which is paddy. And in case of mustard to sugarcane, the Rabi season crop is mustard and the Kharif season crop is sugarcane. And these are the results in tabulated form. I'm also generated a result map which shows there are wheat to paddy, wheat to bare land, mustard to paddy, mustard to bare land, mustard to sugarcane, sugarcane to paddy, sugarcane which is in the whole year, which is sugarcane to sugarcane, and then sugarcane to bare land, and bare land to paddy, bare land to bare land, so which is just like an unused land, and then non-crop to non-crop, so that might consist of plantation or water body, which is a non-crop land, and then the barren land which hasn't been used for cultivation. So these are various classes that have been generated for the crop rotation map. And the crop rotation accuracy map shows the overall accuracy of 80% acquired with the help of optical data and knowledge from crop calendar of the study area. And it is a benefit for decision makers, administrators, and policy makers to take reliable decisions about a particular region regarding land management and natural resources. So these are some additional resources which you might refer to, which are relevant to the subject and the study area. So how will this research impact? So the benefits of crop information system can therefore be summarized as accurate estimates resulting in price stability, timely and accurate forecast of production allowing governments to plan domestic and foreign policy and actions, accurate forecast enabling optimal utilization of storage, transportation, and processing facilities, and detection and timely knowledge of harmful effects on crop growth to assist in taking remedial measures. So I conclude with this. thank you all for your kind attention and support. And I'm really happy to be part of this masterclass tutorial series. And stay safe and healthy, everyone. Bye bye.